All right, in the last couple of videos, we solved a complete triangle. And you notice that the first step that we used involved law of cosines, and that tends to be kind of tedious, so then we would switch over and we would use law of sines for the next thing that we were finding, and then eventually we were just finding the third angle, and there we just used the fact that the sum of the angles in a triangle was 180 degrees. What I want to do is just focus on that first step of the law of cosines, because that does tend to be the longer calculation that's a little bit more involved. So I'm going to give you some information here, giving you two sides and one angle in a triangle, but I'm just asking you to find the third side using the law of cosines. Do make sure that you read the directions carefully as you're looking at problems. If you're asked to solve a triangle, you're asked to find all the sides and all the angles. Here, I'm just focusing on one side. Okay. Now, I kind of like to have a picture, so I'm going to draw myself a picture. Okay. Now, A here is just 9 degrees. That's a very small angle, so I'll draw at least that much to scale. And then let's see. Let's make this B, because this would be a longer side. That's going to be 24 feet. And then this would be C, and that's 12 feet. Okay. Now, I'm not claiming that the picture is drawn to scale. I did make A be a small angle, and I made B bigger than C because I could see that the side opposite B was bigger than the side opposite C. But again, when you're drawing a picture, it really is just a place to put your numbers. So it's not important that things be exactly to scale, and I'm not claiming that this is. In fact, I don't think that's twice as long as that. I just was not that careful about measuring anything out. Okay, but I want to find side A, which would be this side here, and I'm told to use the law of cosines. Now here, since I'm looking for side A, I'm going to use the version of law of cosines that sort of singles out side A and angle A. So that's going to be A squared is B squared plus C squared. Remember, it starts out looking kind of like the Pythagorean theorem, but then minus 2 times BC times cosine of A. Again, I find it really helpful to just write out the formula first before I plug things in. And at this point now, I can plug in 24 and 12 and 9 degrees. Okay. I'm going to suggest that you pause the video and work this out. Let's see, if we're solving for A, let's include the units in our answer and round to the right number of significant digits. Actually, before you pause, let's just review that. If I look at my numbers and the number of significant digits, 24 feet and 12 feet, those are pretty straightforward. Those are both just two significant digits. 9 degrees is also two significant digits. And that one throws a lot of people because there's only one digit, but yet we count it as two significant digits. Remember, for degrees, no matter how many degrees we have, the degrees to the left of the decimal, and the decimal would be right here, always count as two significant digits, regardless of the number of digits that actually appear. Okay. So I'm going to suggest that at this point, you pause the video, solve for A using this version of the law of cosines, and you'll be rounding to two significant digits. Okay, so go ahead and work that out. Welcome back. Okay, so A squared is going to be 24 squared plus 12 squared minus 2 times 24 times 12 times cosine of 9 degrees. Okay. So I'm going to go ahead and work that out, remembering that that's A squared. I'm going to make sure that my calculator is in degree mode, and then we'll enter in 24 squared plus 12 squared minus 2 times 24 times 12 times cosine of 9 degrees. Okay. And I get 151, 151.0 blah, 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 blah. Okay. All right. A is going to be the square root of this lovely number that I have. So on my calculator, I'm going to not clear the screen. I'm going to hit square root and the answer key, And then when I hit equals, it plugs in that previous answer. And so I get A is 12.29 blah, blah, blah. If I'm rounding to two significant digits, I'm rounding to this place. This is smaller than 5, so that would just drop out, and I would say this is approximately 12, and the units would be feet. Okay. Again, if your calculator has that answer key, that's a really nice thing so that you don't have to enter in all of these digits. If not, remember that the square root of a number is the same as that number raised to the 1/2 power. So your other option is to use your exponent key with an exponent of 0.5, and that just prevents you from having to type in the square root parentheses and have parentheses around all of that. You could certainly do that, but I find that the more parentheses you're entering into your calculator, the more likely you are to just make a careless error and hit the wrong key somewhere.